internet saya kong ke ni? Okey, Assalamualaikum. Assalamualaikum dan selamat malam semua. Selamat datang dan selamat kembali ke program 30 Minutes with CheMEE. Harap pelajar semua dalam keadaan sihat sejahtera. Dan terima kasih sekali lagi kerana bersama kami pada minggu yang ketiga. Jadi pelajar yang hadir boleh tulis nama dan kelas anda di ruangan komen. Okey, untuk minggu yang ketiga ini, tajuk yang akan disampaikan adalah benzene and its derivatives yang akan dibawakan oleh Madam Liza kali. Jadi tanpa membuang masa, saya persilakan Madam Liza untuk penyampaian beliau. Dipersilakan.
Terima kasih Miss Akila. Okay, Assalamualaikum, selamat malam semua. Okay, saya Madam Noliza and I'm assigned to discuss with you chapter 13, benzene and its derivatives. Okay, student, I hope you are ready. Okay, I believe most of you have learned this chapter. So tonight I just want to do some revision with you this topic. So let me start with introduction of benzene. What is benzene? So it is aromatic compound and it has odor, something that we will notice if benzene is placed near with us. So in our syllabus, how to know benzene or aromatic compound, there are some criteria that are very similar to this aromatic compound. Okay, so this compound actually will be in cyclic. Yeah, I just simplified for you. It must be planar. And it has completely conjugated double bond. And the last one obeys Hückel's rule. That is the 4n plus 2, right? So I think everyone knows this. Okay, 4n plus 2 and n actually starting from 0. Yeah, so 4n plus 2, if n is 0, so we have total number of pi electron is 2. When n is 1, so 4n plus 2 equals to 6 and so on. So this is our first revision. Can you identify compound shows aromaticity? Di sini boleh mengenal pasti aromatic compound. Okay, the first one only has 4 pi electron. So this one actually non-aromatic compound, right? Okay, compound number 2 has 1, 2, 3, 4, 5, 6 pi electron. So this is aromatic compound. Okay, and number 3, this one cannot be aromatic compound because it has only 4 pi electrons, right? Number 4 also cannot be aromatic compound. Okay, compound number 5 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you refer to the table, you can see that when your n is 2, So 4 and plus 2 equals to 10. So this one is aromatic compound. Okay, the last compound has 1, 2, 3, 4, 5, 6. So also aromatic compound. Okay, guys. So aromatic compound must have cyclic structure, planar, completely conjugated double bond, and obeys or satisfy Hückel's rule 4 and plus 2. All right. And then Kekuli structure. This one proposed by Kekuli. Yeah. So we have cyclic of 6 carbon atoms, conjugated double bond, and each carbon attached to 1 hydrogen atom. Okay. So I go fast. Yeah. And then the resonance. Okay. Instead of writing 3 double bond, we just use draw cyclic in the ring. So this is hybrid resonance hybrid of benzene. Then okay, now nomenclature of benzene. Okay, remember this is just a revision. Okay, so mono substituted benzene. Okay, so if fluorine attached to the benzene, we call it fluorobenzene, chlorobenzene, nitrobenzene, bromobenzene. So benzene is the parent name, right? IUPAC role. Okay, this one, some common role, common names that we can use as IUPAC name. So you can see that combination between benzene and methyl, we give name as toluene. Okay, hydroxy and benzene become phenol. Amino, NH2 and benzene is aniline. SO3H and benzene, the name is benzene sulfonic acid. Carboxyl and benzene becomes benzoic acid. Okay, and then C double bond O CH3 and benzene is acetophenone, and C double bond OH is and benzene become benzaldehyde. So there are seven common names that can we use as IUPAC name. All right. Then, very interesting in benzene, instead we use number, we also can replace by letter, that is O for auto, M for meta, and P for para. So auto actually can replace number 1 and 2. Okay, look at the example. 1,2-dibromobenzene. So if you don't want to use 1,2, you can use O or auto-dibromobenzene. Okay, 1,3 we can replace with M. M stand for meta. Meta dinitrobenzene. And the other one is para, 1,4. Okay, so this is 1-chloro-4-ethylbenzene. So chloro and ethyl, we arrange them according to the first alphabet. Okay, so chloro, we consider first letter C, and ethyl, we consider the first letter E. That's why the name is 1-chloro-4-ethylbenzene, or we replace 1,4 by using P or para-chloroethylbenzene. Okay. similar to this one. This one we use common name as IUPAC. So in this chapter, in this sub-chapter, toluene. If we choose toluene as your parent name, we choose toluene as parent name. So CH3 must get number 1. Okay, so this one, the first molecule is 4-bromotoluene or para-bromotoluene. Right, then NH2 and benzene become aniline. Therefore, this amino get number 1, chlorine number 3, so become 3-chloroaniline or meta-chloroaniline. And finally, combination benzoic acid and benzene, so become carboxyl and benzene become benzoic acid. Therefore, location for benzene get number 1, nitro number 2. So the name is 2-nitrobenzoic acid or benzoic acid. Okay, and then as usual, if we have more than one, so we use tribromobenzene, 1,2,4-tribromobenzene. And then we use a number to give lowest possible number to the substituent. Okay, and the substituent we must consider the first alphabet, right? So this example, 2-bromo, 1-chloro, 3-iodo. So 2-bromo we consider alphabet B, 1-chloro, the C, iodo, I. So list them according to the first alphabet. So 2-bromo, bromo come first, and then 1-chloro, 3-iodo, benzene. Alright. So this one saya dah sentuh sikit tadi. Okay. Skip. Now, just now we have discussed benzene as the parent name. Now benzene as substituent. Okay. So when benzene becomes substituent, we call it phenyl. Phenyl, the formula is C6H5 or short form PH. Yeah, so phenyl ataupun the structure looks like this. We have benzene and then one dash. Maksudnya dash here means we remove one hydrogen atom. So we have C6H5. Benzene actually C6H6. When benzene becomes phenyl, the formula is C6H5. Okay, so here we can write R or anything. R boleh, OH boleh, COOH also can. Right? So phenyl is C6H5. Okay, remember that. So example, 2-butene. This is 2-butene. The longest chain, this is alkene, and then we start numbering number 1 from the left. So it become 1-phenyl-2-butene. Okay, in this one, okay, numbering starting from the right. So 2-phenyl ethanol. Okay, so this one, 1, 2, 3, 4, 5, 6, 7. So 2-phenyl 7 is 1, 2, 3, 4, 5, 6, 7. Heptane. 2-phenyl heptane. Right? And then beside phenyl, we also oftenly use benzene. Please differentiate phenyl and benzene. Benzene, you have benzene and CH2. So this is benzene. Ini adalah phenyl. So when benzene attached to bromine, it become benzyl bromide. Benzene attached to OH become benzyl alcohol, benzyl alcohol. So this is not IUPAC name, yeah. This is common name, yeah, common name. All right. Then the chemical properties of benzene. So benzene actually undergo electrophilic, aromatic, substitution reaction. Yeah? Electrophilic, aromatic, substitution reaction. Okay, so actually in this reaction, a hydrogen atom is replaced by electrophile. Ya, hydrogen atom is replaced, ya, hydrogen digantikan dengan satu electrophile. Okay, so this is the summary of reaction in benzene. Okay, so tonight I don't want to focus on uh, mechanism. Sorry, so I just want to do some revision on naming the compound and the reaction. Right. So this is a summary for the reaction in benzene. So the first one is called nitration of benzene. So benzene react with concentrate nitric acid, and then we have concentrate sulfuric acid, condition or temperature 50 to 55 degrees Celsius. So one hydrogen is replaced by electrophile. The electrophile is NO2. So it becomes nitrobenzene, right? Next one, halogenation. So we use X2. X is chlorine or bromine. And the catalyst FeBr2. Yeah. So we replace hydrogen with halogen. Depends. X itu halogen itu bromine or chlorine. So halogenation. Okay, next, what we call as Friedel-Crafts alkylation. So we have alkyl halide, RCl, AlCl3. Okay, so we have alkyl benzene and HCl. But remember, sometimes the alkyl can do rearrangement. Okay, the alkyl can do rearrangement. So you have to check whether the alkyl can rearrange to give you more stable product, right? And the last reaction is Friedel-Crafts acylation. Friedel-Crafts acylation. So we have acyl chloride, RC double bond OCl, acyl chloride, AlCl3, the catalyst. So we remove hydrogen from benzene and we remove chlorine from acyl chloride, become HCl, and then C double bond OR tu kita gantikan dekat tempat hydrogen tadilah. So the product will be ketone, ketone. So this is Friedel-Crafts acylation. So there are four major reaction in our syllabus for benzene lah, yeah. Right. Then mechanism. I don't want to touch the mechanism tonight. Nanti you boleh study sendirilah mechanism. Alright. So example ni Friedel-Crafts alkylation. Alright. So benzene with 2-chloropropane. So we have isopropyl benzene, and then benzene with 2-chloro, 2-methyl propane, and we have third butyl benzene. Okay, and then remember in this reaction R sometimes can do rearrangement. Okay, so this is for rearrangement. So when we use a primary haloalkane, so better we check. Okay, berhati-hatilah, mungkin ada rearrangement. So in this reaction we have butyl benzene and butyl benzene. Butyl benzene ni comes after then apa lagi, Friedel-Crafts acylation. Alright. Okay, this one. Side chain reaction dari oxidation. Please remember that benzene does not react with oxidizing agent. Means that benzene cannot be oxidized. Benzene cannot be oxidized. But if alkyl benzene, some alkyl benzene could be oxidized. Tak semua. Ada alkyl benzene yang boleh dioksidakan. Okay, kita tengok. Okay, macam mana kita nak oksidakan alkyl benzene? At least the alkyl benzene must have at least one benzylic hydrogen. Benzylic hydrogen. Okay. So where is benzylic hydrogen? So let's say you have toluene. So this carbon CH3, this carbon attached to benzene. So CH3, H itu adalah benzylic hydrogen. Okay. H3 is benzylic hydrogen. At least kalau ada satu benzylic hydrogen, so that compound can be oxidized. Okay, that's why when we oxidize toluene, it will become benzoic acid, because in toluene we have benzylic hydrogen. Okay, so benzylic hydrogen actually hydrogen atom that attached to a carbon bonded to the benzene ring. Okay, this one semua boleh dapat lah. Example, toluene. This one it will change to benzoic acid lah, because it contain benzylic hydrogen. This one, benzylic hydrogen. And then ethyl benzene also, ini cari benzylic hydrogen dulu, ada kan? So it also can be oxidized into COOH. And this carbon, kalau ada lebih carbon, we can have carbon dioxide and water lah. Okay. Alright, so this one also can benzylic hydrogen. Ini pun ada benzylic hydrogen. Okay, nanti boleh tulis sendiri. Okay, this part, this one ada, but this one tak ada. Tak ada. Kat carbon ni, tak ada benzylic hydrogen. So you will have CH3 on the left will change to C double bond O, OH. But carbon on the right will stay as C, CH3, 3. Okay, this carbon do not have any benzylic hydrogen. Okay, halogenation of halogenation of alkyl benzene. Right, so it will undergo, kalau benzene tadi dia ikut apa tu, aromatic, electrophilic aromatic substitution, but for alkyl benzene, halogenation of alkyl benzene, it will undergo free radical substitution reaction. Okay, so we will replace hydrogen from CH3, not hydrogen from the ring. We replace hydrogen from alkyl group with halogen, and the condition we need here under sunlight or UV, right? Because we need UV to initiate the homolytic cleavage to form free radical, right? So itulah yang that's all untuk benzene. So kita tengok sikit exercise saja, ringkas-ringkas saja, because benzene ni not many reactions, ya. So kita akan cuba ingat balik apa yang actually you dah buat pun. Jadi I need you to complete or to name A, B, C until F ni, until G. Okay, kita boleh mulakan. So the first one, benzene, bromine, and FeBr3. Therefore, we have, kita buat sama-sama ni. Bromobenzene. Take out hydrogen from benzene, replace with bromine. So A actually bromobenzene. Okay, yang tahu boleh terus jalan, ya, terus buat. Alright, and then benzene, we have CH3, CH2, C double bond OCl, AlCl3. This one actually Friedel-Crafts acylation. Friedel-Crafts acylation. Alright, so the product is C double bond O, and then CH2, CH3. Right, then C reaction to produce C, benzene with concentrate, nitric and sulfuric acid. So this is the nitration of benzene. So replace one hydrogen and with an O2, nitrobenzene. Okay, and then comes to reaction D. We have alkyl, haloalkane, and then with catalyst AlCl3. So this one we use primary haloalkane. Remember, maybe it can do rearrangement. So the product of D will be C, K, CH3, CH3, CH3. After rearrangement, dia boleh buat rearrangement. So this is the answer for D. right? And then DE, okay, E, benzene, CH3Cl, ASL3. This one is Friedel-Crafts alkylation. Friedel-Crafts alkylation. So you will get E. E is toluene. Toluene. Replace one hydrogen with methyl. So toluene. Okay, from E, oxidation. We use KMNO4 and then heat, acidic. So toluene, the carbon that bonded to benzene has benzylic hydrogen. So it undergo oxidation. CH3 change to COO, H. So you have here benzoic acid. And F, from E change to F, we use chlorine in tetrachloromethane or chloroform, and under UV, so we replace hydrogen from methyl, CH3 change to CH2Cl, and we have chloromethyl benzene, right? Then ni lagi, okay. So we go very fast here. From benzene, we use reagent. This one we name the reagent. So benzene, reagent A, we have NO2, so name reagent A. Benzene, reagent B, bromobenzene. Benzene NC, dapat third butyl benzene. Benzene ND, we have 1, 2, 3, ni ketone, and then benzene plus E, dapat produknya ethyl benzene. Ethyl benzene with F, benzoic acid. Ethyl benzene and G. Dapat chloroethyl benzene. Alright, ada soalan tu. Mana 2-bromotoluene. Boleh ke 2-bromotoluene undergo oxidation? 2-bromotoluene boleh oxidation sebab toluene tu boleh dioksidakan. 2-bromotoluene 2-bromotoluene macam ni lah. Kalau you oxidize KMNO4, this part dia akan tukar kepada COOH. Boleh. Okay, bromination ni bergantung you pakai apa. Kalau bromination under UV, dia akan attack CH3 ni. You akan dapat, kalau dengan UV, bromine under UV, so you dapat CH2Br lah. Okay. Kalau you pakai bromine dengan FeBr3, okay, dia sebenarnya boleh, tapi ini di luar silibus kita sikit sebab dia bergantung ada pengarah autopara director. So itu di luar silibus kita. Boleh sebenarnya. Jadi yang confirm boleh oxidation ini boleh. Kemudian yang semua boleh lah sebenarnya. Cuma ada satu saja yang pengarah autopara tu di luar silibus kita. Kalau you baca buku yang lebih lanjut lah kan. Kalau you tak tengok nota saja, you baca buku, dia ada jawapan ni. Boleh buat. Ya. Yeah? Okay, last kali. Ni saya bagi jawapan lah. Untuk A, nitrobenzene, reagent. And then B, bromine in FeBr3. C ni ada dua jawapan. Kita boleh guna third butyl chloride ataupun 1-chloro 2-methyl propane. And then D, CH3, CH2, C double bond OCl dengan AlCl3 tertinggal. Okay, the rest ethyl chloride AlCl3, F oxidizing agent, and G ni chlorine in inert solvent, and UV. Okay. Alright, last one. Soalan begini, dia biasa dia suka naik dalam our final lah. Actually our final nanti dia bukannya bagi one reaction, satu reaction, tak. Reactionnya tu berbagai dan ada juga soalan yang berbentuk analisis macam ni ya. So soalan ni kita kena baca, kena cari maklumat dan kita kena digest satu-satu lah ya. So kita tengok soalan dia. When an aromatic hydrocarbon AA C8H10 is heated with acidified potassium manganate 7, a compound BbC7H6O2 is obtained, and draw structural formula of AA and name the AA, write equation. Okay, so soalan macam ni kita bukan boleh main hentam jawab saja. So kita kena cari maklumat dulu. Maklumat yang pertama is aromatic. Aromatic hydrocarbon. Bila nampak perkataan aromatic, kita terbayang di sini dia mengandungi struktur benzene. Okay, tapi sekarang ni benzene kita ada C6H6 kan. Sekarang kita ada C8H10. So macam mana kita nak buat, nak rangkakan sebab dia minta structural formula ya. Kemudian bila kita baca lagi acidified ni kita tukar terus pada H+ ataupun H3O+. Kemudian dia kata heated buat simbol. Potassium permanganate. Ni kalau tak tahu, tak belajar kimia lah jawabnya. CheMEE. Tukar kan. Jadi kita dah dapat reagent dia kat sini. Okay. So reagent ini adalah oxidizing agent. Oxidizing agent lah. Jadi, so ingat, benzene sahaja, kalau benzene sahaja cannot be oxidized. Saya dah ulang tadi kan. Benzene tidak boleh dioksidakan. Tetapi alkyl benzene boleh. Alkyl benzene boleh. So, sekarang ni kita ada C8H10. Kita tak boleh guna benzene sebab benzene tak boleh oksida. Benzene C6H6. Jadi kita kena tukar sikit C6H5 ni, jadikan dia phenyl. Phenyl adalah C6H5. So tolak kan C6H5. Jadi tinggal lagi pada kamu C2H5. Macam mana rupa C6H5? Saya dah tulis tadi. C6H5. Dan kita replace one hydrogen. So ini rupa C6H5. Jadi C2H5 ni apa? Ini adalah R. R boleh jadi metil, boleh jadi etil. Ya. Jadi C2H5, cuba letak C2H5. Tapi jangan buat C2H5 lah, pecahkan ya. So kita dapat CH2, CH3. So dah dapat struktur AA. Kemudian kita check balik. Bilangan karbon mesti 8. So kira 1, 2, 3, 4, 5, 6, 7, 8. So dah ada 8 karbon. Hidrogen setiap bucu ni, sini ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Betul. So ini adalah structure A. Yeah. So draw the structural formula of AA. Dah dapat. Namakan ethyl benzene. Ethyl benzene. Okay, write an equation to show the reaction above. So you take ethyl benzene, CH2, CH3, KMnO4, H plus and heat. So we have benzylic hydrogen here. So this part change to C double bond OH. And ada lagi satu carbon ni, CH3 ni, maksudnya dia ada campuran carbon dioxide and water. So done. Okay. So ini sajalah ya. Saya pun tak boleh bagi banyak. Maksudnya lepas ni saya harap awak dapat sedikit maklumat. Saya nak sangat dia membantu kamu, tapi kamu kena rajin lagi lah ya. Kamu semua boleh belajar, cuma rajin sikit saja lagi. Kamu boleh dapat insyaAllah ya. Okay. Ada apa-apa lagi?
Okay, terima kasih Madam Mariza atas perkongsian. Pelajar ada apa-apa soalan? Kalau ada soalan, anda boleh tuliskan di ruangan komen. Okay, nampaknya dah tak ada je. Tak ada soalan?
Okay. InsyaAllah nanti dia faham.
Okay.
Okay,
so
so baliklah ya. Okay, thank you very much. Selamat belajar semua. Okay, thank you. Bye-bye semua. Assalamualaikum. Belajar rajin-rajin ya.
Waalaikumsalam. Okay, jadi untuk belajar juga, especially regarding organic, jangan lupa untuk practice mechanism at least one reaction a day untuk bantu awak ingat mechanism tu. Buat mind map untuk hafal reaction, sebab ya, daripada pegang pada reaction banyak, baik buat mind map, sekurang-kurangnya boleh masuk. Okey, jadi terima kasih sekali lagi kepada pelajar kita kerana sudi meluangkan masa bersama CheMEE hari ini 43 minit ya bersama CheMEE. Jadi kita akan jumpa lagi pada waktu yang sama, hari yang sama, minggu hadapan dengan tajuk Halo Alkin. Assalamualaikum dan selamat malam.